Okay, there we go. Good. It's wonderful to have Kenway here as our first guest of the year. Who has not been to a growing up science event before? Okay, several people here. So the basic idea is that faculty, usually it's faculty, talk very openly about their life and career stories with an emphasis on the things that didn't go so well. So failures, doubts, struggles, detours. And the one goal is to sort of like lessen the gap between trainees and faculty, so that students and postdocs see that, and undergraduates see that there's faculty are like normal people who also struggle with the same things as them, or have struggled with the same things. And in part, the series is also in order to make certain difficult topics easier to talk about within the community, right? So some topics are still a little bit taboo, and you have to keep up your facade that everything is going smoothly. And hopefully, this series can contribute to changing that. So Kenway's story you might already have read. I found it super interesting. He's going to tell his story now. I'm going to minimally interrupt if I have a question now and then I might ask. But floor is yours.
All right. So hi everyone. I'm Kenway. I am a research assistant professor, nominally employed through downtown, though I'm joint with uptown, so I'm kind of back and forth. But rather than where I am now, why don't we start with how I got started? So I grew up not far from here, about 30 miles east out on Long Island, with the twin brother. So we were the sons of immigrant parents. So both my parents came over in the mid-50s from China. So they came in large part because their families came here after the communist takeover. But they didn't come to the States until, there's a little bit of history, until after Sputnik was launched. The US government changed their immigration policies to favor people with scientific and mathematical backgrounds. That's where my parents came over. So my mom was a math teacher. My dad was a civil engineer. So they settled in New York City, and like the story, actually this is a story my wife and I relived not that long ago. When they had kids, they moved out of the city into the suburbs. So I was born up at Columbia, and myself and my brother, and then my parents took us immediately out of the hospital to Long Island. So we grew up in Long Island. We were one of the few Asians in our community at the time, which, I think in retrospect was more isolating than I realized at the time. You're a kid, you're growing up, you kind of feel like, that's the life, that's the world that is, because that's what exists. But my brother and I were pretty happy. My parents really pushed academics, so math was important, reading was important. Now that I myself have little kids, I imagine that there was much more pushing and prodding than I realized at the time. But we liked it. I think, like most people, if you do well at something, you enjoy it. I think my brother and I both enjoyed doing well at school. I think we were that much smarter than other kids. I don't think so, but my parents pushed. My mom was a tiger mom before the term was invented. She was the one who was always at board meetings. I think the board hated her. So my mom was primarily the reason my brother and I, we skipped 2 grades growing up. We skipped 6th grade and either 10th or 11th grade, depending on how you count it. So we graduated early. We took a lot of extracurricular classes. My mom enrolled us in, there's a program called CTY that Johns Hopkins runs for academically, advancing youth. So we did that as a summer program 1 year, not your typical firewood kind of camp. So we did that. I, studied math early, studied calculus early. So we graduated 2 years early, and we applied to a lot of colleges. Surprisingly, I think we applied to the same college. So I have a twin brother. We applied to colleges at the same time. We applied to the same colleges, and we got into and rejected by the same colleges. And so we both ended up at MIT, I think. And that was actually a great thing for both of us. There's an old saying about MIT that you leave more normal than you go in, whatever that means. And I actually think it's true. I think, as socially maladjusted as my brother and I were at the time, we were not the only ones at MIT. So, and we were also, other things, we were not the smartest ones, like growing up, you tend to find yourself the smartest one in class. Well, when I got to college, I was clearly not the smartest one in class. And I don't know if MIT has the same system now, but when I went there, it was pass, fail the first year. And that was the only thing that saved me. I was a good studier. I like to study. I put a lot of energy in it, but I think, the coursework, that shift from like a public high school. Oh, that was the other thing. My mom was very adamant that the public high school system, at least where we live, was not adequate, which was part of the push for extracurriculars, but also a push to get to a more academic-minded institution. That was also a big upshift in terms of amount of work, in terms of what was expected. So when I got to college, I thought I was going to be a physics major. I really liked math. It was at Columbia University when I was a freshman or a sophomore in high school. I went to one of these extracurricular programs on the weekends at Columbia. I remember thinking I felt so grown up because I would get a cup of coffee, which I was not allowed to drink normally, at the coffee cart at the station and ride on the subway by myself in the city, listening to a U2 on my cassette, my Walkman. I'm dating myself right now. So that was a physics-minded class. So I thought I'd be a physicist, like I would study quantum mechanics, or I'd be a mathematician. But I found those classes a real struggle. And the only thing that saved me was pass fail my freshman year. I think I got a C in physics, or would have been a C, and I don't even remember math. But so that was a quick shock to my system, and I think I always wanted to be a physicist because it was something I was good at in class. But it's not the same as being like something that you want to do for a living. So what was I going to do? So I kind of spun around for a bit, but in my family had always emphasized medicine as something that was both professionally stable and also honorable. So my maternal grandfather, who I never met, was a doctor back in the day. And to my dad, my dad's an engineer, and obviously good at MIT. Engineering is something that's valued academically, but my dad was also very adamant that one should not be an engineer for financial reasons. I don't think he quite foresaw the rise of software engineering. So he was a civil engineer. Civil engineers often work for government contracts. So it's a stable profession, but it's not found in Google. So my dad was pretty adamant I should not be a civil engineer, certainly, or an engineer at all. My mom was pretty adamant that medicine would be a good career. But both of them were I think agreeable to the idea of being a scientist, because scientists, in their view, was an honorable profession, if not a wise financial decision. So I actually started studying biology with the intent of going to medical school. So this was back in the day. This was early 90s, where molecular biology was still kind of blossoming. So this was still in the day where clone a gene, get a job was sort of the mantra. So people would find relevant genes for a particular disease, and that would sort of be a springboard to a career. It took me a while as an undergraduate to find my footing in the research lab. For those of you guys who are undergrads out there, and I teach undergraduates now for the CNS Honor Seminar. I know it's really hard. You don't know much about the different fields. Getting a job is often just being able to get your foot in the door. So my first job as an undergraduate was in an X-ray crystallography lab, which was the most boring thing ever. Right? And the computers were cool. They were running on old VAX systems at the time. But your job was really just filling wells with chemicals and titrating the different amounts, different directions, and trying to grow crystals. It was interesting to see the results, but the day-to-day was absolutely boring. So I did that for 1 or 2 semesters as a sophomore, I believe. And then I did research in an undergraduate research program at Rockefeller I think summer after my sophomore year. That was also, I don't remember actually much about that. I don't think it was a great welcoming. That particular experience was not a great welcoming experience for an undergraduate trying to find this footing. So that wasn't very useful. Where I really found my footing was when I found an undergraduate job in the lab of Robert Weinberg, who's a cancer biologist at MIT. And he is most famous for finding the retinoblastoma gene, which is the first tumor suppressor gene. So I think, and what was eye-opening about that experience for me was just, it was a big lab, busy, lots of postdocs, lots of grad students. I was fortunate enough to find a position with a postdoc who was very interested in teaching me. I mean, I was doing a lot of busy work, right? I was running gels, I was doing immunoprecipitation assays, but he would incorporate me in the science and the reading, and that really helped me kind of get a taste for doing science. So when it was time to apply to school, and I just as an aside, I think MIT was also good for a lot of for social reasons. So it was a place where it was easier to fit in with peers. I started doing things outside of science, or academics, which I did not do a lot before, whether because I did not have time or did not have the initiative or feeling that I could do it. So I started, I joined the rowing team. I was on the dorm government, things like that. And I actually found that really rewarding. But these are things that I continued afterwards. I coached for a while when I was in graduate school. But so my brother and I lived in the same dorm. We were the same double major. So I ended up double majoring in biology because that was sort of my main concentration of interest. But because I was at MIT, I also did a chemical engineering degree. Primarily because there was a lot of overlap between that and biology. It required a lot of extra classes. If we're talking about failure, there was one class in chemical engineering, was thermodynamics, was notorious for having terribly hard exams. And I think the professor was sort of sadistic about absolutely having average scores that were like 35% out of 100 on regular exams. I remember there was one exam where I thought I did terrible. I think I got like a 35%, but the average on that test was 14. As a point of principle, I don't think that's a good teaching experience, because if your students, I mean, you want a Gaussian distribution around 50 at worst, right? But I found I found chemical engineering to be academically interesting, but nothing I was interested in doing as a career. At least at the time I was studying, it was very process oriented, it was very industry oriented. That's where undergraduates would go after they were leaving. So everything was geared towards adjusting chemical reactions to maximize the dollar amount at the outside of at the end of the batch process, which, interesting academically, but not what I was interested in career-wise. So I applied.
Just a question. So did the age difference with your peers play a role in this period of your life?
No, much less so than in high school. So in high school, I think my brother and I were outsiders. We did not belong, especially, we skipped the grade between 10 and 12. We kind of combined 10 and 11. So by the time I was a senior, right, I was 13 when I started my senior year, and I was taking AP Calculus. Oh no, sorry, I took Calculus when I was a freshman. So when I was a freshman, I was in AP Calculus, 12, with a bunch of seniors who were like getting ready for prom, talking about their cars. I remember one guy had the coolest, just back in the 80s, a denim jacket with a spray paint of Jimi Hendrix on the back. So cool. But that was not my life. I was a curiosity who sat in the back. I was quiet but knew all the answers. That was not college. College was much more of a place where I felt like I fit in. So after all the research, I was really caught between applying to a graduate program or applying to an MD program. And honestly, I don't know if this was a smart decision, but I ended up thinking I was going to apply to MD PhD programs primarily for the financial incentive of having it paid for. So if you don't know, MSTP programs are funded by the government. So some MD PhD programs are fully funded. So you don't have to pay for med school, you don't have to pay for grad school. So that was really one of the deciding factors that made me think about applying to MSTP programs rather than MD programs. Aside from the fact that I wanted to do research. I didn't know what research I wanted to do because I was, at that point, I found the molecular biology rewarding, but I did not find it as intellectually interesting as broader questions. I found it very focused on, what protein was connected to what transcription factor. And I think at the time it was not made clear to me, or I was not aware of how to think about those things and how they subserve larger processes that were interesting, whether it's biological function or cognitive disease or what have you. It was my view was very much what bound to what. And to me, I wasn't sure I wanted to pursue that. Regardless, I got to medical school. So I went to Harvard. My brother went to Tufts, so we were actually in the same city, which is nice because we lived together for a year. I was also not, I don't know how I stumbled into Harvard. When I got there, I realized there were a lot of people who were who had been focused for a much longer time on getting into Harvard and being at Harvard than I was. So there are people who were very serious about being Harvard doctors. I remember there are a couple guys who go to bars and try to meet people and do what they call dropping the H-bomb. So I'm happy to go to Harvard. For me, I was just kind of struggling to catch up with all the medical, because I was ostensibly pre-med, but I was really on a molecular biology track in college. So, we took human phys, we took a couple really classes, but there's no anatomy class in my undergraduate. So I was just trying to catch up to the medicine. But the academics so the way medical school is typically split up, this was the way it was when I was there, was 2 years of classes, typically 1 year of basic anatomy and physiology, 1 year of basic pathophysiology. And then you go to the wards. So your third and fourth years, you're on clinical rotations, you're working with teams, you do general medicine, you do general surgery, you do your subspecialties. So classically for MD PhD programs, you do your first 2 years of classes and you go do your PhD, and then you come back and you do your time on the wards. So I did not know what I wanted to do my PhD in. I got there, but I had a revelation my second year in neuropathogens, where I for whatever reason, I found the link to disease and cognitive function there. And it sort of set up this idea in my head that, what I really want to study is how biological processes link to higher order cognitive function. I found that super interesting. And at the same time, I don't remember exactly how I became aware of it. I became aware of Matt Wilson's work at MIT. He was a guy who was actually an engineer by training, an electrical engineer, who developed a technology to record from many neurons at once, which is commonplace nowadays, but back then was sort of cutting edge. And so I found out, and he was at MIT. And this was before the time there was a real codified brain and cognitive science program. There was no neuroscience or brain and cognitive science major when I was an undergraduate. So I didn't even know about neuroscience until I got in medical school. But I decided I was going to go to MIT and I was going to do my PhD under Matt Wilson. Even though there was, so I applied to the biology program, which was my home undergraduate program. And I remember the director said, listen, you're a great student. We do not let undergraduates in here for graduate school. And the only reason we're going to let you in is because you're going to go work with somebody who's not ostensibly just in biology. Because he was at the time, he was joint appointed with brain and cognitive science. Because it was a very hardcore molecular biology graduate program. So, a lot of, de-staging protein work, a lot of cancer biology. So I did those 2 years of the first couple of years of graduate school were just classes, the first year. And I felt very molecular biology, right? It was DNA, it was restriction enzymes, it was biochemistry. I was kind of still waiting to get to the neuroscience. So it wasn't until I actually got to start working in a lab that I really started learning neuroscience. And this was from the ground up. So I never really took a neuroscience class other than pathophys. So I really found, to me, neuroscience was like figuring out and reading it as I went. So I got to the lab, and this was at a time, for whatever reason, Matt's lab was heavily male. I think it was all male. It was 10 postdocs, 10 people, 5 postdocs, 5 graduate students. Everybody was male. And and a lot of smart people, a lot of driven, strong personalities. And a lot of them are faculty in different institutions now. Actually, Lauren Frank, who just came here last week, he was a graduate student there at the time. Albert Lee, who's at Janelia. Mike Meadow, who's at UCLA. So there were a lot of people who were very smart. So it was another it was another example of me coming and feeling like the dumbest kid in the world again. So when I got to MIT, I felt that way. When I got to the lab, I felt that way too. But eventually, I just kind of put my head down and started doing the work. And Matt was the kind of advisor who was he was always there, but he was always hands-off. He was like, here's what I think you should work on. Go do your thing. If you had a problem, you'd ask him, but otherwise, he would just see how you flew. So I spun around for a couple of years. Peter Diane was there at the time, so we talked about doing some classical conditioning blocking studies on rodents, looking at dopamine neurons. Didn't quite pan out. I think it was hard to reach the dopamine neurons in the rodents to consistently record from them. Eventually, I ended up doing a couple projects. One which ended up in a paper, and one that ended up being scooped by the Mosers. So it was interesting. So graduate school was for me. It was a time where I really felt like I was in my wheelhouse. I was reading research that I really liked. I was learning a lot of different things. I was in my early 20s. So one of the things that happened towards the end of my graduate career. So one of the things that early on, one of the postdocs pulled me aside and said, you know what? And I was a second year grad student. He said, I just want to give you a little piece of advice. You will graduate 6 months from the day that you decide you're done. I said, that's ridiculous. I'm put my head down. I don't work hard. I got ideas. I'm going to finish 3 years. So eventually, I graduated like 6 months after the day I woke up one day. I said, I think I'm ready to go back to medical school. But, in the meantime, I think for me, graduate school was a chance to discover a lot of things about myself. Getting into relationships, getting into serious relationships, finding interests outside of science. That was a time for that. I started riding motorcycles. I started rock climbing. I think a lot of those things, I think from a personal point of view, in retrospect, I can dial down to. So my mom passed away from cancer during graduate school, and to me, I love my mom. She was always my strongest advocate. But it was in a way it was a chance to reflect on like what you have left in life and what you should aspire to. So my mom was always super overprotective. So for my brother and I were only allowed to ride our bicycles around the block. She didn't want us to cross the street, even until we were like 9. So it was sort of a lifting of the shackles in the sense that I no longer had the fear of like disappointing my mom by doing something like breaking my leg climbing or something. So I think at the same time that was sort of a chance for me to think about my own career in terms of what I want to do. My dad's always thought it was a mistake not to go to medicine, so I eventually did not go to medicine. But he's always said, look, you have to make your own choices. So once I finished my PhD, it was just a matter of going back. So I wrote up a paper. We were studying sleep reactivation in the hippocampus. So Matt had actually gotten his job based on a series of studies where he looked at correlated reactivation during slow wave sleep. This idea that you run through the maze, place fields that are co-activated in sequence will co-activate in a compressed time scale in slow wave sleep, more so than before, and more so if they were activated before. So this idea that memory reactivation during sleep, it subserves plasticity of memory. So my work was actually looking at that same exact kind of co-activation, but during REM sleep. And what we found, and I think this is a picture that you somehow dug up for the flyer of me and a rat. Is that you?
One of my students actually did that.
That's a good detective work. I didn't even know that picture existed. So we were looking at rats running on a maze, but we were specifically looking at REM sleep reactivation. And I think it ended up to be like one of my most cited papers to date, not just because it was from a long time ago. And I think it was also I remember as I was finishing the paper, we submitted it. This was back in the day where we printed out paper copies of your manuscript for submission, printed out 5 copies. We were submitting it to Neuron, which had its offices in Harvard Square. So I trucked down to the publication office with a big stack of papers plopped on their desk. But I remember being pushed at the end of my thesis, because this is right around when I was writing up my thesis too, because Matt needed to get his tenure package in. And that was like the one last thing that they were waiting on. So like there was a lot of pressure all around to get that paper in. It did get in eventually. I actually had a very super interesting idea on how reward modulates reactivation, with the idea that there should be biases in place field formation and segregation due to prior reward. It's a little tricky thing to examine because you have to examine whether they're not to reward. And I had a great set of data on it. And the Mosers published a paper in it like 2 months before we started writing it up. Anyways, so I think I enjoyed graduate school. I think it was a great learning experience for me. I think I learned a lot of things I didn't even think I would learn or didn't plan on learning going in. You know, systems neuroscience, and so a little bit of programming. We ran on a Linux environment with Linux. I don't think I fully appreciated at the time how driven one has to be to succeed in academic science. So, you know, I think that crew of postdocs and graduate students I was working with at the time were, I think, the most driven, academically successful group that I've been around in one room at one time, but I did not realize that at the time. So to me, it was just how academic life was. But I think in retrospect, it was a very particular environment at a very particular time, both good and bad. So eventually I graduated 6 months to the day that I realized that I needed to leave. And I went back to medical school, which was again a shock to the system, because I was totally unprepared for being a clinician, right? So there's a trope that MD, PhD students are the people who know all the facts, are super nerdy, know the books, but are terrible people. The only reason I survived in my 3rd and 4th years is because I was the opposite. I knew nothing about facts. Medicine, so you study for your boards. So you board part 1, board part 2, boards part 1, you take the 2nd year of medical school, and you take your part 2s right before you graduate. I did okay in my part 1 boards. By the time I got back after 6 years, half years of my PhD, I'd forgotten everything I learned in medical school. On top of that, there were whole classes of drugs that were invented while I was in graduate school. Protease inhibitors for HIV, non-existent when I left medical school, a whole new thing apparently when I got back. So doctors would ask me questions. You know, there's this classic, you know, doctors will push you until they get you to admit that you don't know. I'm like, nope, don't know that one right away. But I think the reason, and I did find in medical school, is because I had, in the intervening time, managed to learn to like be helpful. And I think I've told this, I think I've told this story in honor somewhere, is that, you know, I would just be as helpful as possible on the boards. Because when you get back to, this is advice for anybody who wants to go to medical school, you know, ostensibly people are there to teach you. Really what their job is on the wards is to take care of their patients. And you as a medical student are really just dragging things down. So your job as a medical student is to learn and also not be a burden. So and I think this is something I learned while in graduate school, is that I just wanted to get things done. I learned, you know, if a resident asks you to go get the charts, you go get the charts. If a doctor asks you to hold the suture, you hold the suture. So I remember one time, I think this was during my general surgery clerkship in my 4th year, where it was an overnight call. I was on with a resident, and you're supposed to go in pre-round before you round the attendings. And I showed up, and the resident had not woken up. He was still in his call room somewhere. And the only thing I did was I started pre-rounding, which means just gathering the charts, getting the numbers, getting everything down so that you can review together with the attending. And when the resident showed up, it was like, you know, thank you for saving me, because otherwise I would have been under the wall. So the only thing the only thing that helped was not any particular knowledge. It was just the impetus to kind of keep things going and get things done. So my one piece of advice for people going to medical school is, when you get to the wards, just remember that you're part of a team, and you have doing things is more important than knowing things. Knowing things is also. I think the other story, and for the times I remember, I was on my neurosurgical rotation. It was just me, the scrub nurse, and the attending. And I don't remember the procedure, but it did. It was something simple. It was like, just throwing a relief burble or something. But I was scrubbed in, the attending was scrubbed in, the nurse was scrubbed in. And the attending just looks at me, he's like, okay, you got this, scrubs out. He's like, just call me when you're done, and walks out of the room. And I just remember looking up, looking at the nurse, and the nurse just wide eyes looking at me. And I was like, okay, I know what I know, I know what I don't know. So I'm just gonna sit here till he comes back in the room. And he came back in a minute later, and I don't know if he was testing or he was just trying to be humorous. But you know, knowing your limits is an important part of, especially in medicine. Know what you're allowed to do, what you're capable of doing. So on my rotations, as much as I struggled with the academic side, eventually I caught up. The other thing was trying to decide what I wanted to do if I was to do clinical specialty. And I had thought all through graduate school that I was going to be a psychiatrist or a neurologist. Both because, you know, I was interested in cognitive function and dysfunction, and I never thought of myself as a surgical person. And then one thing they always say is that you have to determine, are you a surgical person or a medicine person? Obviously, there's things on the border, there's radiology, but to me, for whatever reason, I found on the wards that surgery was much more my thing. I think part of it might have been that compared to the pace of academics where things take so long to evolve, see about a project, get the protocol approved, run the data, 2 years later, you try to get it published, a year later, you do the revisions. Surgery really felt like you have a start time, you have a finish time, but by the time you scrub out, you have to have done what you intend to do, whether it was a good outcome or not. So if there was a completeness and a directness of that interaction that was appealing to me. And physically, I actually enjoyed it. And I think this is something I also got from graduate school because we did a lot of animal surgeries. I enjoyed the procedural nature of it. But, you know, I was not sure that I wanted to commit to a life of surgery, especially neurosurgery, right? Because as you know, it's a very time-intensive endeavor. And the one thing that I was pretty adamant on was preserving time for family life. So my dad never was around when we were growing up. We lived in the suburbs. He got up, left work at 7, didn't get home at 8 or 9 p.m. So my mom would cook dinner for me and my brother. We'd eat together, we'd go to bed, and my dad would eat, and my mom would leave. And I was pretty sure that if I raised a family, because at the time I wasn't interested in kids per se, but I did want to preserve the freedoms of a family life. So I was really at a juncture when I was finishing up my 4th year where I had to make a decision. Was I going to apply for postdocs? Was I going to apply for residencies? Was I going to do something else? And I was really torn. Sometimes I'm still torn about whether or not it was the right decision. And I started filling out my neurosurgery, match applications. But at the same time, and this is interesting for a separate perspective, is I have done my PhD work in rodents. Our lab shared an office space with a primate lab. So it was Matt Wilson's lab working with rodents, Earl Miller's lab, who does work on prefrontal cortex primates. And I was always struck by the degree of control they had over their tasks. I think in retrospect, now having worked on primates, I realized you're trading off external control for internal control. You never know what the animals are thinking. But I was attracted to the link that primates provided to human cognition. But I will admit, I did not do a very exhaustive search of places to do postdocs. I saw Paul Glimcher give a talk at MIT, I believe. And I was really enamored by both his approach to decision. I was enamored with decision making. I love the thought of looking at the representational computations behind neural coding, and I really was enamored with that idea of moving to New York. So, I had friends in New York. I grew up near here. A lot of my classmates from college and graduate school end up here. I thought living in the city would be really great. There's this opportunity to do a primate postdoc in New York. I did not do an exhaustive search at all. I did not look on the West Coast. I mean, there's a lot of people who do great primate work at MIT. I was at Harvard. I was ready to leave Boston. I think, and and that's one of those things that in retrospect in life, you think about what are the things that drive your decisions. At the time, moving and finding a new city was as important to me, if not more important, than finding the exact right academic position. Not necessarily a bad academic position, I didn't do an exhaustive search. I did a very truncated research. So I was right on that pinpoint. I was like trying to decide what I would do. I even considered, maybe I'll apply to residencies if I didn't like the postdoc here. But I came here. So I moved down here, it was 2004, I believe. It was 2004 I moved down here. And I started postdoc. And that postdoc lasted far longer than I thought it would. I think I was technically a postdoc for 7 or 8 years. And it wasn't for lack of work. It wasn't for lack of effort. Primate work just takes a long time. I remember, I published, I think I had 2 primary projects that I did over the course of my postdoc, and ancillary projects, the 2 primary ones. The first one was the one that I was hired to do, and the one that I started working on right away, which was on temporal discounting. Temporal discounting is this idea that subjective value. So Paul does a lot of work on decision variables, subjective value coding, this kind of relationship between economic variables and human instantiation and neural coding. So this idea of temporal discounting and how does value discount with delay to where you get in the future. So my project was to come in and look at that in the parietal cortex. Simple idea, but for whatever reason, that project took a super long time to publish. Okay, so I got here in 2004. I wrote an NRSA for it probably in 2005 or 2006, which is a postdoctoral funding, so a government-funded postdoctoral research project. But that paper, which I thought actually was solid results, we found temporal discounting in neural activity across 2 different animal subjects that correlated perfectly with their behavioral discount functions. It just took a long time to publish. We sent that around to a lot of places. So we went to Nature first, Science, Nature Neuroscience. Eventually came out in Journal of Neuroscience in 2010. And the next paper on a project that I started years later came out in 2011. So just things get backed up. Things take a long time in neuroscience. And I found it very frustrating because I thought it was an interesting finding. In retrospect, I don't think it was as interesting a finding as I thought it was at the time. It was sort of obvious given things that we found and people have subsequently found in other places. But it was something that I worked hard on. I remember when I was writing the NRSA, I was like a second-year postdoc. I remember I was really sick. So this was something that, as somebody without a family, now that I have a family, I miss the ability to just work as much as I want to without outside constraints. I think I was here on Saturday. It's a couple weeks from the NRSA deadline. I was sick as a dog with some flu. I remember it was upstairs on the 9th floor. I remember going to the lab sink and puking, and then coming back to my desk to work on my grant. So that's another time I'll touch on in a little bit is this idea of like trading off family work life and professional career. So, so the other thing that I worked on as a postdoc, which I think has actually been the more influential work in the long run, was this idea of relative value coding and divisive normalization. And I will say, at the time, nobody thought it was an interesting idea. I remember Paul specifically told me, because I think the idea originally came up as a rotation project for a graduate student, Lord Rod. I was like, oh, why don't we look at value modulation by something outside of the city? I think Paul gave me a career talk at that moment. It's like, this is not the kind of project you want to do if you want to. This is just not a good idea. And I wasn't sure I disagreed with him at the time. I think it's turned out to be interesting because we've kind of found different ways to apply it to different things. It kind of gave us insight into a computational principle. We've applied that in different ways to behavior and everything since then. But I didn't see it as an important project at the time. I think we did it because it was something we could do rather than something that we needed to do. I think there's things that come from them that seemed like more like the right things to study because they were interesting. This was just sort of a what happens if we do it. And then maybe if there's a lesson there, is that maybe those things sometimes do have interesting answers. It was an unanswered question. So since that time, I think, I parlayed that work to, an R1. So I was a PI on my own R1, but not here, but as a research assistant professor. So one of the things is once I started looking for jobs, I found it really difficult to even get callbacks. So I applied to many faculty positions around 2011, right after that paper came out. And I don't know if it wasn't interesting to people, if our approach, this is around the time where people were started advocating, I think two things. People started advocating do more multi-channel, multiple site kind of recordings, which was not what I was focused on. This is also around the time that optogenetics and rodent speak started to become a big thing. There were a lot of hires in optogenetics. So I'm not excusing it because I think there are people who are great primary researchers who have got jobs in the meantime, but I found it very difficult to even get callbacks for faculty positions. So what I decided to do was to stay on here as a research professor. So for those of you guys who don't know, it's a non-tenure track position that doesn't come with its own line, so you have to find your own money. It doesn't come with its own space, so you have to have somebody who's willing to be your sponsor. So those are the bad things about that kind of position. It's not stable. It's not as lucrative as a financial in the financial sense. But the things it affords are I can do my own research as long as my sponsor, who's Paul, agrees. I do not have some of the obligations that faculty members do for in terms of committee and teaching. I do teach. I teach in the honor seminar of CNS, but that's because I enjoy it. I think I'm helping out the department. So
sorry, did you ever consider moving away from monkey?
I have. In fact, I am now. So I think, particularly since COVID, I think maintaining an active monkey program has been hard. So I had R1. It was a 5-year. We got a couple interesting papers out of it, but renewing that came right around the same time. I was trying to renew that around 2017 or 2018. I could not get that one. So we've been struggling for primate funding ever since. I think Paul had a monkey grant. I think that eventually finished. And we've had a hard time renewing monkey grants. Even harder than that, I think, is finding people who are interested in doing NHP work now is hard. And I don't blame graduate students. I think if I were a graduate student now, I'd be probably more focused on optogenetics than NHP work. Because NHP work takes a long time. There are a lot of questions that can be. So I think one important thing to ask when you're doing monkey work is this something that cannot be answered in another organism, both either in humans with neuroimaging techniques, in rodents with recording techniques, or even with better optogenetic manipulation techniques in rodents. I mean, I know people are translating that up to primates now, but for me personally, I think the things I'm interested in now have more moved towards the behavioral computational side than NHP work. And that's driven partially by circumstance, the fact that it's hard to find people who want to do it. Partly by funding and partly by where my own interests lie. So in the meantime, especially since COVID, because COVID kind of caused a shutdown of the lab and primate work for a while, I've been focused more on computational behavior. So I have a joint appointment uptown, partly because Paul's a joint appointment uptown. But that's actually allowed me to open up more collaborations with people doing a wide range of things. So my wheelhouse really is sort of computational modeling focused on representations. I think we've done work with Beauchamp, for example, looking at dynamic models of this kind of circuit process that kind of spun off from this idea of normalization, but has really moved on to different things like disinhibition and decision circuit modeling. But I've also struck up collaborations with people uptown who are totally not directly, involved in systems neuroscience. There's a great initiative U19 on oxytocin that I've attached to now as a computation person. So where we're doing levels of modeling that kind of span between circuit modeling up to agent-based modeling of social behaviors. So I found a niche, I think, that's sort of centered on computational modeling, behavior, and neurophysiology inspired modeling, but not direct neuroscience. And that's sort of an adjustment for me, because as a person who's got their start heavily influenced by math and physics. I'm not a mathematics person now, right? I cannot do derivations like mathematicians can. I'm not super well versed in linear algebra like I should be, as if I took math tools. But I'm cognizant enough of them and know enough about them that at least I know who to ask. And I could read some papers and some help. I think, particularly as a PI, I think asking questions is as important as, answering them. So I found a position where, and I'm to me, the position I'm in now is not the position I want to be in 2 years from now or 5 years from now. I'm hoping some of the work I'm doing now I can parlay into a more stable position of some kind. I will admit there's always an attraction to things like industry. As you guys know, there's graduate students in data sciences who are constantly leaving to go to the industry. That temptation is always there. So I have a young family now. We have twins. They're not that young anymore. They're 6 now. But having a family, the benefits of academia to me, particularly versus clinical medicines, I have the time to be there. If I want to work later, I'll work later, and I'll drop them off at the bus stop. If my son started Little League last year, they need a coach, I coach Little League. Because I have the freedom to, especially to do computational work, to adjust my hours as needed. I end up doing a lot of late hours, but that to me is worth it. Whereas, I always think about if I were practicing neurosurgeon, I'd be a lot more tied to the hours of my work than I am in academia. To me, particularly now that I've had kids, that is more than a worthy trade-off. So, and that's not something I knew at the time when I made that decision, but it's something that I am glad. That's a decision that I'm glad I made.
And the cons of the research professor job are starting to weigh on you, or?
So I'm not young anymore. And I you get to a certain point in life when you start thinking about what's the next final 20 years start looking like. And I think as much as I like this position, I think if I don't find a more stable, I think, okay, so I think to me the drawbacks of this type of position are, financial stability is one. I think status in the field is another. The ability to get grants, for example, the ability to serve on grant committees, how you're viewed by others in your field. I think a lot of that as non-tenure track faculty, it's harder to it feels like you're outside the circle. So I don't have a perfect answer. I don't know what's going to happen. I don't know where I'm going to go. I'm happy with the work that we're doing. I get to work with great graduate students at postdocs, but it feels like a half and half sometimes. Like I have 1 foot in academia and 1 foot on my own. So I don't think I would prefer to go to industry, and I think it would take a lot for me to go, because I enjoy the people here and I enjoy the milieu of being in academics, and I enjoy conferences. But academics is not easy. Being a professional academic is not easy. So I don't know. I mean, I'm in a position where we're fortunate as a family, and we live in the suburbs. My wife has a good paying work from home job, so we're okay. We're doing fine financially and socially. So I think this question is from a professional point of view. What do I want to do? And I think in the next couple of years, I think I have a fork decision. Do I stay in academic science, however, whatever it looks like, or do I find something else? As you know, as an academic, I don't have a lot of immediately desirable skills, right? I'm not a great programmer. I'm not, a great businessman. I have certain skills I think I'm good at, but they're not they're not very marketable. So, it may be just a matter of nuance and finding the right kind of position. But, I think it'd be hard to be in a position that was not touching
were to involve moving away from the city, that's consider that?
Not for the next, not for a while, because so we live, my wife and I, so right before the pandemic, actually, in 2019. So we had kids when we were living in Brooklyn, twins. We were living in this tiny, essentially one bedroom and a half, in the ground floor of Brownstone in Bed-Stuy. It got way too crowded. So we decided to move. My wife was adamant that we move that year. She was very prescient because this was the summer before COVID. I was like, I don't know if we found the right house. I don't know if we found the right town. Maybe we should wait a year. She's like, no, we gotta move now. And so we moved the summer right of 2019. So right 6 months before COVID. And we love where we live. So we live in northern Westchester. It's a river town. It's got great schools. It's got rivers. It's got hills. It's just a great place to live. And we chose to move out of the city because the education for kids in the city is hard.
Yeah.
So I think we'd be hard pressed to move out of our current town. This is the other thing about starting a family is I think, at least for me, it's limited where I'm willing to look for a job. So I think I'm willing to look within, a reasonable commute. That's going to change as the kids get older, I think. But right now, for the next couple of years, I think I want to be within reasonable commutes. I will note New York City is really kind of on the border.
Yeah.
Because so for me, my commute door to door is a little under 2 hours. So some of that's train time. I work on the train.
Yeah.
But some of that is not useful time.
Right.
So during COVID, I was driving. That was driving to the city is not a fun. But that is wasted time.
Yeah.
Being on the train, at least I can work. As much as answering emails counts as work.
It does. So are you doing things differently as a parent than how you were raised?
I would like to think so. I'll be honest, I don't have a good memory of how I was parented up to this age. I don't remember much before 3rd grade. I think we're trying. We're both my wife and I are first-time parents. We're kind of winging it as we go. I think we try to hold the principles that we think are important. Like, we're trying to keep them responsible. We try to emphasize the positive instead of negative. We try to emphasize consequences. My wife is very adamant on them getting good sleep. And I would say that is one place where, I thought she was being too rigid early on. It is totally the right thing. They started sleeping in their beds through the night at like 4 months. And they've been great ever since. She's like, gotta be in bed at 8. It's totally the right thing. No, I think raising kids is one of these things that was very eye-opening because in neuroscience we have all these ideas about cognition and learning, and when you actually see it in person, it's just amazing how little control you have as a parent over what eventually happens. You can only control the inputs, right? And that's totally not even talking about when you get to school age and you have to deal with peers. It's a whole other problem. Minecraft. Why is that such a thing? Mike.
So the transition from purely soft money to something more stable. Now, going straight to academics is one thing. To a tenure line. And people have done that here. Lynn did that.
Mike.
And Mike. And people have, you're also connected to med school, postdoctoral mind transition very slowly from very insecure position up there to something that seems to be long lasting. Do you see possibilities of that downtown or uptown for you that might happen so that the transition won't be so?
That's a good question, but I don't know. I've looked. I think the possibilities are always constrained by money and that availability, space. I think I love downtown. I love the CNS community. I wish the communities were more connected than they were. I think uptown is starting to create a serious footprint in systems, which I personally find academically interesting. I don't know which affords the better opportunity. I will push in both directions, but I don't know the answer. I think these are the kind of things that are hard to figure out from a bottom-up perspective, and anything that happens tends to happen top-down, I think. But you know, it's a good question. And you know, the med school has an easier transition, but I think they also offer less support for their faculty. Even if you come in as a tenure track faculty, you know, you're expected to carry a lot of your salary.
Yeah.
So you know, it's not that one's better than the other. I think they're very different, I think, professional situations. So you know, I'm keeping my options open. But you know, it is a shift. Like just the fact of shifting to a more computational focus is a big shift in terms of where do you send your papers, where do you send, what conferences do you attend. So I think I'm adjusting that as I go too.
What also came to mind is that in other countries, especially in Europe, a position like yours would actually be very stable, right? It could be a lifelong job, even though you're not necessarily top of the pyramid.
I don't know if anybody noticed, but there's the Nobel Prize in Physiology and Medicine just went to the two scientists who discovered the way to make mRNA stable in an enteral cell. And I forget her name now, unfortunately, but the woman,
Calico, yeah.
yeah, she was a research assistant professor for many years. She was never tenure track, actually.
Yeah, there's hope for
Just
you.
hope.
Speaking of the randomness of how things happen, the story about how the two of them happened. They were fighting over a Xerox machine.
Yeah.
I think there is a lot more happenstance and perchance in life than we would like to recognize.
So there's a couple of questions. So what would you want your lab to look like if you were to manage your own lab?
I am not a proponent of huge labs. And I would like to run a lab with a couple of postdocs and a couple of graduate students. Maybe a research tech or two, depending on what was required. So to me, an ideal lab for the kind of work I want to do is 4, 5, 6 people. But I think that is something that depends a lot on PI and community. Some PIs like to run big labs and are good at it. I am not. You know, I like a small nucleus of people who are like-minded, but you know, the drawback of that is that small groups tend to be very controlled by outsized personalities. So you do run a risk of instability, which I've seen in the past as well. But yes, something around that size.
Talking about stability, the next question is, if the position of assistant research professor had more stability, would you consider it for the long term?
Good question. I think I would, but I still think the stability is only one part of that equation. I think status in the community, the ability to have your own graduate students, ability to sit on funding committees is also an important aspect of being tenure track versus non tenure. So qualified, yes.
Right. Any other questions from either online or here? If you're online, you can unmute yourself. Okay.
I have a short comment.
Yes, go ahead. Yeah.
So because I work with Kenway just said he's not very good at computation, but he does. But my question is actually, Kenway, like along all the time of like your high school or graduate school, I believe during that age, the computation is actually, computers in hardware is developing very fast, right? But you never mentioned about in your training, you actually like specifically have time to learn computation. I'm just curious, like, can you share some of your experience how to like pick up computations, even if you are not on like specific training track about computation?
I think it depends if you're talking about computation as programming or computation as mathematics. I think programming is easier to pick up on your own. There's a lot of tutorials out there. I think mathematics is something that, for me, is harder because I think it requires a little more formal training. So I think the mathematics that I've picked up is harsher than I would like, because I don't have the time to sit down and dedicate myself to a long period of focus. Programming is easier for me because that's something that I enjoy and I also pick up just on the side. I can do a little bit here, a little bit there. I remember in graduate school, this was graduate school, time management. So I remember I learned Perl simply to create my own reference manager in Linux, which is a total waste of time. But I did learn Perl. So, you know, the one advice I give, or one piece of advice I give undergrads thinking about grad school, thinking about what discipline they should choose, or even undergraduates, it's always better to focus on a quantitative discipline early. It's harder to learn that on your own later. Like to me, biology is built on facts and concepts, which are easier to get out of a book. Whereas things like quantitative approaches to things, I find easier to learn. So if I'd learned computational neuroscience as an undergraduate, I think personally it would be easier for me to pick up principles of biology for a book. So, I mean, that's not the route I chose. But that's the advice I give.
All right, unfortunately, we have to wrap up. Thank you so much.
Thank you for everything you do, Wei Ji.
Okay.
Serious.